Okay? So a reminder, your quiz tomorrow will cover Monday, Tuesday, Wednesday. That's today. Material. Okay? I'm asking you to get your calculator out. I'm going to show you some stuff on your calculator that will be on the quiz tomorrow. Okay? Make sure you practice it. It's not bad. All right. What did I tell you was the base in your calculator for the logarithm? Base 10. Well, what if I have log base 3 of 5? How am I supposed to figure out what that equals? Okay? In your calculator, you only have base E and base 10. So if I ask you to evaluate any other base, you need to know how to put that in your calculator. Okay? This is the change of base formula. Log base A of x equals log base B of x divided by log base B of A. Some of you are like, oh yeah, I remember. If you don't remember it, put it in your brain now. And don't forget it. It's very useful. Okay. Now, notice how whatever is inside of your logarithm heads to the numerator of the formula, and whatever your base is heads to the denominator of your formula. Okay? Well, that base kind of floats a little bit lower. So when you look at it, you know, that base needs to stay lower if you need kind of a way to think about it. Now, base B could be anything. Since our calculators are base 10, you are probably going to use this formula with base 10. Okay? And technically, you could use it with base E, all right? But I'm guessing most of us will choose base 10 to use in our calculator. It doesn't matter. That's the beauty of this formula. It works with any base. So whether you choose base 10 or base E, you can use this formula to calculate a logarithm that is not base 10 or base E. Okay. We're going to go through two examples, but before we actually put them in our calculator, I want us to think about what our outcome should actually be. All right? We know that logarithms are describing exponents. Log base 2 of 2 equals 1. Log base 2 of 2 equals 1. Because 2 to the first is 2. Log base 2 of 4 is 2. Log base 2 of 8 is 3. Okay, we think about the exponent it takes to get there. So, before we actually evaluate log base 4 of 25, I want us to think about what range it's going to fall between. Okay? This is asking us 4 to what power is 25? That's what a logarithm asks. Okay, well let's think about powers of 4 we know. 4 to the first? Okay. 4 squared? 4 cubed? 64? Okay, 25 falls in between 16 and 64. Do you agree? So log base 4 of 25 is going to fall between 2 and 3 because 4 squared is 16 and 4 cubed is 64. Since 25 is in between those, the logarithm base 4 is going to be between the exponents 2 and 3. Okay, so my calculator that I have in my computer was giving me some fits in first hour, but I think that we can all handle it without me pressing the buttons with you. Please find the log button, and bless you, in your calculator, punch in log of 25. Make sure you close your parentheses before you divide it by log of 4. Otherwise, you're going to get a mess. Practice it. I know it seems very easy, but you still need to practice it. Yes. You are, but you need to know how this works. Okay. All right, what do we get? 2.322. And that's in between 2 and 3?
Yeah.
Cool. We do that. Yes. I'll ask for, in this case, 3 decimal places would be good. Okay. Okay, the second one we're going to do is log base 2 of 12. Let's think about what that would be between. Okay, our base is 2. So think of the powers of 2. What's it going to be between? Say it louder, Riley. 3 and 4. 2 cubed is 8. 2 to the 4th is 16. 12 falls between 8 and 16. Okay? In your calculator, go and type it in. Matt, what do you get? 5 what? 85. Sorry, I wasn't quite sure what that second decimal was. Okay, 3.585. If you do not practice this, you will not remember how to do it tomorrow. It's the easiest 2 problems on the quiz tomorrow. Please make sure you practice the change of base formula so you don't forget it. Okay? Yes.
So is finding what it's between just give us an idea so that we can decide?
Well, it kind of like yesterday, like does this x-intercept look reasonable? Okay. If you make a mistake in your calculator, this kind of gives you an idea like, oh.
Because we just automatically trust our calculator.
Right. But sometimes there's calculator user error.
Oh, yeah.
Like if you don't get this parentheses closed, you're going to get a really strange answer. And I want you to be aware when that would happen. Okay? All right, we're going to talk about the properties of logarithms very quickly. And then these are the types of problems that I'm going to have you guys do together as a pod and check off with me as opposed to me doing boring examples for you. Okay? Because I know we're getting to a point in this chapter where I really haven't taught you many new items. Okay? So let's think about exponents. Logarithms are exponents. Okay? They describe an exponent. So let's think about our exponential properties. If I had a squared times a to the 5th, we are multiplying with same bases. What do we do with our exponents? We add them. So when we have a product inside of our logarithm, then we're going to take that product and we're going to break it up into the sum of 2 logarithms. If there's a product with 3 values, you would break it up into the sum of 3 logarithms. You okay, Caitlin?
Yeah.
Okay. Please understand that log base A means any base. So base E would also work, but I don't think you need to actually write this down because log base A is encompassing all logarithms. Natural log is just log base E. Okay, I'm just trying to save us a little bit of time. All right, our quotient property. If I have bases that are the same, that have exponents, and we're dividing, what do we do with those exponents? We subtract them, okay? So inside of our logarithm, if we are dividing, then we can break that up into two logarithms where we are subtracting them. Bless you. Okay, and log base A encompasses all logarithms, and so natural log is log base E. That would be a part of it, but I don't think it's necessary for us to write it down. Okay, it can be log base anything. Natural log would be a part of that. Okay. Just making sure you're good. Okay, and our last one is the power property. What do we do when we have an exponent and then that expression is raised to a power? We multiply them, okay? So if we have some sort of exponent inside of our logarithm, then that exponent actually is going to be multiplied out in front of our logarithm. Do you see how that works? Yeah. We take the exponent and we throw it out in front, multiplied to our logarithm. Okay. And log base A means anything, so natural log's a part of it too. Now, this is something that you did last year, okay? So I have 7 problems where I ask you either to expand or condense. When I ask you to expand, that means you're using all of the properties to write it in as many logarithms as you can, okay? I mean, not as many, but just break it apart into the sum or difference of logarithms. When I ask you to condense, you're going to take all of these logarithms and squish it down to one logarithm. So what I'm going to ask that you do, everyone works together. You leave nobody behind. So the first problem you're going to do together, and you're going to send somebody up here to check the answer. They're going to go back, report to your group. When you have the first one done, you will go to the second one. A new person will then come up and check their answer with me. Okay, these are your examples in your notes, okay? But you are working together as a group. Okay? They're in the order I want them to be in because I think that they are in